in any coding language, whenever we begin to think about code that we want to repeat, we're thinking about functions. And another important point about functions is that whenever we have this rather ambiguous lines of code that we want to use to do some operation, functions give them a comprehensible name. So we can name these functions in a way that helps us to understand what the code within them does collectively. So here we're talking about operating on numbers. And one operation that we're doing is an add operation, subtract, multiply, and then down here you can tell by the operator that this is a division. And we're passing into this function 3 arguments. One argument is a value upon which we'd like to operate. The second operatable value, and then a definition of what operation we'd like to do. We've set the value of this operation keyword. We've set that value to 0, in which case it's going to default to this. But if we override this operation 0 value, as we are doing down here with this third argument in this function call, see, we're overriding this operation, and it's going to run this first part of this if statement like this. So let's run this and see what happens. Of course, first we have to run our function and make sure it's available. Then when we run this, it's taking this add keyword and replacing this 0 and saying operation is equal to add, so we run this portion. We can change this to sub and run it again, and now it's going to be 4 minus 2, and we can change it to mult, and it's going to multiply 4 times 2 to get an 8. Now when it comes to these positional arguments, order matters. It doesn't really matter with addition because 4 plus 2 and 2 plus 4 is the same, and it doesn't really matter with multiplication because 4 times 2 and 2 times 4 is the same, but with minus and division it does actually matter. Let's leave this operation argument blank and run this, and it's going to say, well, 4 divided by 2 is 2, but if we reverse this and put a 2 in the first position and a 4 in the second position, it's going to give us 0.5 because 2 divided by 4 is 0.5. So what we're looking at is position arguments and keyword arguments right up here. Let's talk for a moment about namespace here, and we'll use this same function to talk about namespace. With global namespace, a variable that we create has access from anywhere inside the program. So let's create a global variable called a random variable, and let's set that equal to 10. And then down here, let's add, we'll do a plus, and we'll add random variable to this, and we'll see what happens. We need to run this again so random variable is available to us. So we can access random variable from inside this function now because it has global scope. And so if we run this, actually we want to put add back in here, and we run that, it's not going to be 6 anymore, it's going to be 16 because this is 4 plus 2 plus 10. Now what if we want to access random variable outside of this function too? We can do that. We can just run this. It's going to say it's 10. But what if we turn this into a local scoped variable rather than a global scoped variable? Move this inside the function, run that again, and now when we run this, well, let's actually change this number to 15 and run this. It's local because it's inside the function now. So we have access because we're calling the function and it's available inside the function. But when we try to call a random variable from outside that function, let me clear the kernel so it forgets that initial run. And let me run this again. So now random variable 15 is there. We still get 21, and right here, if we run that, we get an error because random variable is not defined. So global scope is when we define a variable outside of a function, but local scope is when we define a variable inside a function.